Hi, today is Thursday, April 30th, and we are recording this math meeting on Thursday, April 30th, the last day in April. You know what month it's going to be tomorrow, Demarian?
Yeah. Hold on. Okay. Oh, it's gonna be
What comes after April?
it's May.
That's right. It will be May. Okay, our first question is this right here. And I'm not sure if you can see it or not. When can you read it?
What? Hold on, Miss Six.
Can you see that?
Yeah.
Okay, what does it say?
Quinn read 1/4 of a book. Wait, go up.
Can you see it?
I can't see the first word.
Quinn read 1/4 of a book. This Jesse read.
Jesse read the same amount of the book, which diagram could show how much of the book Jesse read.
So how much did Jesse read?
2/4,
That's what I was thinking at first,
but it's
but
not.
I think they mean he didn't read double what Quinn read. I think they mean that I think they mean he read the exact same amount. So what is the exact same amount?
1/4.
That's right. So
Too
which
easy.
one is it? A, B, C, or D?
See,
That's right. C. That is what I think. And so I wrote Jesse. Wait. Jesse also read 1/4. So C. And that's what you said. Number 2. Can you read that? Read
Megan
on
has
number
8
2.
classes each day. How many classes does she have in 9 days?
Okay, so she's for in 9 days, each of those days, she has 8 classes. So how many classes does she
She got
have in those 9
72.
days? That's right, 72. You're going to multiply the 9 days by the 7 classes in each day. Good job. So I wrote down this. I just wrote 8 times 9 equals 72. So B. Number 3. Mr. Farina is 42 years old. He is 7 times as old as his daughter. How old is his daughter? Mr. Farina. Can you read that too so you can see the question too?
Mr. Farina is 42 years old. He is 7 times as old as his daughter. How old is his daughter?
And this one's a hard one. Look at the answers. Read the answers.
Oh, this is easy. She is 6 years old.
That's right. But for some of the kids at home, it might be hard because they see that it says how old is the daughter, and they see that it says 7 times as old as his daughter, so they're going to think to multiply. But if you multiplied 42 times 7, you'd get a really big number, and his daughter is younger than him. It's going to be a smaller number. So you have to divide. You have to figure out, just like Demarian said, that 42 divided by 7 is 6. So if the daughter is 6 times 7 is 42. And I think the way that he was able to answer that so quickly was he knew that 42 divided by 7 was 6, but I think he also knew his facts families. He knew that 6 times 7 is 42, 7 times 6 is 42, 42 divided by 7 is 6, and 42 divided by 6 is 7. He knows that in a fact family, it's the same 3 numbers, and there's 2 multiplication problems and 2 division problems. And that's how he's able to do mental math and figure out the answer really quick. This one, Ned's grandmother. Can you read that, Demarian?
Ned's grandmother turned 67 in 2012. In what year was Ned's grandmother born?
Okay, so this is a really hard question. So I want you to work on in your notebook or on your paper for a few minutes on this, and then we're going to talk about how we get to the answer, okay? So let's look at the numbers. Ned's grandmother turned 67 in 2012. So 2012 is a year, and her age is 67 in that year. So I want you to write on your paper what you think the answer might be, the year that the grandmother was born. And I'm going to give the kids at home some time too to work on it.
We didn't know how to start, where to start, what to begin, what number to put that. We were a mess over here.
Demarian, your screen is frozen on my side. That's why I'm looking in so closely. Talk and see if I can see you again. Okay, there you are. All right.
It was because I was doing this.
Oh, okay. I see you now. Yay.
It's kind of a hard answer.
Oh my gosh, yes, this is very difficult. I'm going to show you guys how I came up with an answer in just a minute. And I'm imagining that you guys are doing subtraction problems in order to try to find the answer, which is a good way. And if you come up with the right answer, that's fine. But with age and years, I like to make a number line because for me, it helps me see what the answer is better to make a long number line. So I'm going to let you work on it for a few minutes, for about 30 seconds, I guess. Are you finished, Demarian?
No.
Okay, keep working on it for at least 30 more seconds because I want you to challenge your brain to come up with an answer, even if you can't come up with an answer. So then I'm going to show you the way I would do it. Keep working.
Thank you.
Demarian, get back down onto your paper and work.
Okay.
Just do some subtraction problems and stuff like that. Because you know that from the year 2000 to the year 2012 is 12 years. And so then you can take 67 and subtract 12 from that. And see how old she was in the year 2000.
So did you get anything that she was saying a little bit?
And then once you know how old she is in the year 2000, then you can try to see how many years before that she was born. 67 minus 12 is 55. So she was 55 in the year 2000. So she was born 55 years before the year 2000. So what is 55 years before the year 2000? Well, 1950 is 50 years before the year 2000. And so 55 years before the year 2000 is 1945, because 50 minus 5 is 45. And that is a lot of subtraction problems. And that is the correct answer,
I know you didn't.
1945. And another way to do it, besides doing a lot of subtraction problems, like I said, is to make a really long number line. And when I started this number line, I made it backwards. I started with this year, 2020, and I went 10 years back and made 2010, then 10 years back to 2000, then 1990, then 1980, 1970, 1960, 1950, and I was counting backwards. See, there's 2012 between 2010 and 2020, and it's two hash marks in front of 2010 because it'd be 2010, 2011, 2012, and I count backwards. So I'm trying to get to 67 because she's 67 years old. So I counted backwards 2 to get to 2010, and then counting backwards 10, 20, wait, 10, 10, 20, 30, 40, 50, 60. So at 1950, I got to 62. It was those 10, 20, 30, 40, 50, 60, and then those 2, so 62. And I was like, wait, she's not 62, she's 67. So I knew I had to go back even further 5 more years between 62 and 67. So I got to 1945. And I'm going to tell you, this is a very difficult problem, and that is a lot of figuring out to do. And I know you guys can do it. You can, because you think about it logically, but it just takes a lot of time to figure it out. You just have to keep working on it until you count up all those numbers. Okay, she's in 45. If she's born in 1945, she's 1 in 1946. She's 2 in 1947. She's 3 in 48, 4 in 49, 5 in 1950. So you just got to keep counting. This one was even more difficult because you were counting backwards instead of up. In a lot of questions, it'll ask, oh, if someone was born in 1945, how old are they in 2012? So you're counting forwards. But this one, you were counting backwards. They said that she's 67 in 2012. So what year back in the day was she born in? So that's counting backwards. So it's even more hard, but I know you can do it. So our answer we came up with was 1945, okay? The next one, can I get you to read this estimation problem, Demarian? Estimation. Doug?
Doug reads 67 pages on Tuesday, 43 pages on Wednesday, and about 50 pages on Thursday.
Estimate
the total number of pages Doug reads over the 3 days. Explain how you find your estimate.
So when you estimate, what do you do with those numbers?
Plus?
No, not what operate. Yes, that's correct. You are adding those together. But for the estimating part of it, we're not gonna add 67 plus 43 plus 50. We're gonna do different numbers. Do you remember what that's called?
No.
Rounding. Let's round 67, round 43, and round 50, and add them together. Because this is an estimation problem, not just a regular problem. So write down 67, 43, and 50. And then go ahead and start working on rounding those numbers. Looks like we're rounding them to the nearest 10th place. So you find your place and look next door. So underline the 6 and then look next door at the ones column, and that's a 7. So you need to remember whether you round up or if it stays the same. What number does 67 round to?
70.
That's right. And what number does 43 round to?
40.
That's right. And does 50 need to be rounded?
No.
Nope, it stays the same. So you have your 3 numbers now, 70, 40, and 50. Go ahead and add them together and tell me what answer you came up with. And I'll tell you. And kids at home, you be working on it too. Make sure you line up your columns correctly. All those zeros need to be in one column. And then the tens place all needs to be in the second column.
Is it 108?
Nope. Add them again. That first column should be all zeros, so your number should end in a 0.
One, 2, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Huh. Is it 200?
No. Make sure your equation looks like this. I'm covering up the answer. 70 plus 40 plus 50.
So you write it down?
Yeah.
70 plus 40 plus 50. I'm going to wait a little longer because I know the kids at home are working on it too.
You write it down.
70 plus 40 plus 50.
Equals what?
Did you get an answer? Are you stuck?
No.
Okay. Just let me know. I'll give you a hint.
Okay, that's right.
You got it?
Tell her what it is.
Oh, that's not 60.
Yes, it. Tell her.
That's
You got
right.
up
No,
there.
you don't.
You do, Mom.
And tell her what the answer is.
16.
What? You got the zeros.
160.
That's right. I heard you say it before. Good job. 160.
Mom, I said 16. No, it's not 16.
All right. One last question, you guys. This one, can you read this one? Number sense. Good job, Demarian. Jacqueline received, is it too blurry?
85 and change.
85
And look,
cents.
85 cents.
Yeah.
And change. And on Tuesday, Friday, she received 25 cents and change. change at lunch without, what's that word called?
Calculating.
Calculating.
Without calculating.
Without
Keep
calculating.
going.
How can you tell what whatever
Whether
what
Jacqueline,
Jacqueline
sorry, Jacqueline,
Jacqueline received more than or less than
$1
$1 in total change?
in total change. So we're looking, this is kind of just a thinking question because it said don't calculate. So it says that she received 85 cents on Tuesday and she received 25 cents on Friday. And so it says without calculating, without writing down those numbers and adding them together, how do you know she got more or less than $1? Can you think of a way with money that you would know whether she got more or less than $1? Think about 85 cents and think about 25 cents. What is 25 cents? Do you know what coin 25 cents is?
Coin.
What kind of coin is 25 cents?
What is it called?
It'll come to you.
A quarter.
A quarter, that's right. And so on one day she got a quarter back. And then on another day, it says she got 85 cents back. So I want you to use your paper to figure out what the coins are for 85 cents.
So I draw pictures of it?
Yes.
Of 85 coins?
No, you could put 85 pennies, but when people give back change, they give you the biggest coin back first. So first you need to find out how many quarters. And then once you find out how many quarters, go down to dimes, nickels, pennies, and so forth until you get 85 cents. So start for 85 cents, start making your quarters first.
It takes 8 quarters.
No. Each quarter is 25 cents. And what you need to do is you need to start memorizing this information. You need to be able to count by 25s because it helps counting money. So 1 quarter is 25 cents. 2 quarters is how much is 2 quarters? How much do you think 2 quarters is? If
50.
each one is 25 cents.
Ooh. 50.
50, that's right. This is information that you need to start memorizing, Demarian. 2 quarters is 50 cents or half a dollar. So you have 25, 50, and then how much is 3 quarters?
75.
That's right. So you need to know, and then how much is 4 quarters?
3 quarters. What?
How much is 4 quarters?
$1.
$1. That's right. You need to memorize that. It goes 25, 50, 75, $1. So if on Friday they got back, was that the day they got back? Oh, on Tuesday they got 85 cents back. So you know they got back at least 3 quarters to make 75 cents. and then they didn't get another quarter back because that was $1. So in order to make 85 cents with your money, I need you to write this down. I need you to write the 3/4. Demarian, are you still there?
Huh?
Are you still there? Demarian, go ahead and write down the 3/4 for the 85 cents.
I did already.
Okay, 3/4, and then you need to write how many you need to go to the next one down, which is a dime, which is worth 10 cents, and write down how many dimes
3/4.
to make the 85 cents.
Oh.
So it's 3/4 and how many dimes?
That's only 1/4, 1 dime.
That's right. 3/4 and 1 dime makes 85 cents. And then it said on Friday, she got 25 more cents back, which is 1 more quarter. So draw that 1/4 next to your 3 dimes, 1 dime, 3/4, 3/4, 1 dime, and draw 1 more quarter because she got another quarter on Friday. So draw a circle with a cube. And now, without doing any calculations, without adding any of those numbers up, does she have more than $1 or less than $1?
More.
More, that's right, because 4/4 is how much?
4/4 is 75.
No, 3/4 is 75. How much is 4/4?
Oh, $1.
$1. So that's, and then she has a dime on top of that. So that's how we know. Very good. That's how we know that she had more than $1. And on my page, I just wrote it all out. I said, I know that 4/4 is $1. So then I wrote out 25 cents is 1/4, 50 cents is 2/4, 75 cents is 3/4, and $1 is 4/4. So then I wrote she received 1/4 on Tuesday, and on Friday she received 3/4 plus 1 dime. That's what you came up with. And then in all she receives 4/4 and 1 dime, and that is more than $1. So that's how you know that it's more than $1 without doing the math where you add and use decimals. We know how to add and use decimals, though. We could have added and used decimal places if we had wanted to, if the question hadn't told us not to. We could have just done 0.85 plus 0.25, and that is 85 cents plus 25 cents. Then we would have done 5 plus 5 is 10, carry the 1. 1 plus 8 is 9, plus 2 is 11. Place your decimal point right there, and we would have came up with this answer: 1 and 10. 1 and 1/10, or the way we read it like money, is 1 and 10 cents. $1.10. So that is a faster way to do it, just using numbers and decimal points. Okay, so yesterday we were talking about compatible numbers, and I told you that we'd come back to that today. And we figured out that we could do 240 divided by 3 very easily because they're compatible numbers. 240 divided by 3 is 80 because 24 divided by 3 is 8. And so 240 divided by 3 is 80. So I'm going to do a little game with you where we're going to use compatible numbers to do a couple of problems. So I'm going to do number 1, 450 divided by 5. Can you do that in your mind? We're using compatible numbers. Instead of doing 450 divided by 5, Damarian, do 45 divided by 5 and then add a 0. What's 45 divided by 5?
Hold on, let me see.
What times 5 equals 45?
$225.
No. What times 5 equals 45? Do your fact family.
Oh,
Campaign files.
it's 9.
That's right.
9.
So if 45 divided by 5 is 9, then 450 divided by 5 is 90. You add a 0. Okay, let's do the next one. 360. Listen, 360 divided by 6. What is 360 divided by 6? First, think about what is 36 divided by 6.
Huh?
First, okay, we're going to do the long question, 360 divided by 6, but we're going to do it in our head. Because for 360 divided by 6, we're going to look at 36 divided by 6 first. What is 36 divided by 6? Think about your fact families.
6.
6. So is the answer just 6, or do we have to add a 0?
Add a, I don't know. Add a 0.
Add a 0. So 360 divided by 6 is 60. 36 divided by 6 is 6, and 360 divided by 6 is 60. We're going to do one more,
Number 6.
and I'm going to let you do that one on your own, okay?
Okay.
210 divided by 3.
You left, Miss Hickson. Mom. 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 Miss Hickson left.
Damarian, can you hear me?
Yes,
Can you hear me, Damarian?
you left.
Are you there? Damarian, can you hear me? Damarian.
Yes.
Damarian, can you hear me?
Yes.
Can you hear me, Damarian?
Yes.
Thumbs up if you can hear me.
Sure, Mom.
You can't hear me? Okay, I lost my camera, but I can see you, okay?
Say yes. Shake your head.
I'm sorry, I lost my camera, okay? It's gonna be all you now, all right? All right. I can't hear you, but I can see you, okay? So for the last question, sorry about this. For the last question, did you do 210 divided by 3? Yes? What did you come up with?
Okay. Tell her. Hold on. Just like this. 1 second. Okay, your answer. 210
Okay.
210
divided by 3.
divided by 3.
So how do we do 3 times what equals 21? 3 times what equals 21?
Mama, that is 7.
Okay, put your 7 at the top. Multiply 3 times 7. And I told you to.
3 times 7 is 21.
Okay.
Sorry about this, Demarian.
21 minus 7.
I can see you. I just can't hear you. And
What?
you can hear me, but you can't see me.
21 minus 0.
Okay, so what are you going to bring down?
The 0.
Okay, so what do you got left?
But what's that 3 up there? Right there.
3 times what equals 21 back?
You going so hard on.
That's right, because when we get off, we got a whole list. Do your work so you can tell
I
her.
am doing
Is
it.
it, tell her, what is it? So you got the 7 up there?
So when you get your answer, just show me on your paper because I can't hear you.
3 times 7 is what?
It's 21.
Okay, so 7 times 3 is 21. Take away 1 and 1. It's the answer is 70. Put up 7 fingers.
7.
Yes. 7. 7 with a what on the end?
0.
She can't hear you.
7 plus a 0. That's right. 70. 70. Good job. If you can see me right now, I'm giving you the thumbs up. Good job, Lauren. We'll see you tomorrow, okay? Bye-bye. Bye.